Now, you know that the motor division of the nervous system, the two motor divisions, are autonomic and somatic. Right? We're not bringing up somatic next semester because we've already covered the muscular system. We've already covered voluntary control of skeletal muscle. So next semester is all about smooth muscle and cardiac muscle and glands. So really it comes down to autonomic nervous system and endocrine system. So we end this semester with nervous, and we start 431 with endocrine. And then you've got your two control systems up front, so that as we progress through 431 and cover digestive and urinary and respiratory and cardiovascular and reproductive, now you have the two control systems. You know how they work, and now you apply them. So autonomic doesn't go away. 13, you're not going to see much of that show up in 431. 15, none of it's going to show up in 431. We cover it because it's part of the curriculum, but just to be honest, 14 is the most important. Overview. We're looking at the motor division. Where did it go? I had this problem earlier. Hang on. It's a new issue that popped up all of a sudden. This happened this morning too. I cannot figure out why. There we go. Okay. Motor division of the nervous system. We've got somatic and we've got autonomic. We're done with somatic. We're moving on to autonomic. And autonomic can be divided into sympathetic and parasympathetic. And we talked about this, right? Sympathetic division mobilizes body systems during activity. During activity implies physical activity. Whenever you're engaged in physical activity, whether it's exercise or running from the tiger that's chasing you, the sympathetic nervous system becomes active. Sympathetic is responsible for fight or flight. It carries out the response to stress. For the response to really make sense, always think of stress in the context of a physical stress. Exercise is a physical stress to the body. It's a good stress, and we adapt to it, and it actually benefits the body, but it's stress nonetheless. Running from the tiger, physical threat to the body. Right? Physical activity is going to get you out of that situation, whether it's running, flight, or fighting the tiger. So ultimately what you're doing with the sympathetic division is you're preparing the body for action, for physical action. And that really means making sure the skeletal muscles get what they need for you to overcome the crisis. And what they need is lots of blood flow, lots of oxygen, lots of nutrients. Parasympathetic. Parasympathetic dominates whenever there is no threat. So most of the time, right now, right? Everybody is experiencing parasympathetic tone. That's the system that's most active. Sympathetic activity is minimal. The functional nickname of the parasympathetic nervous system, rest and digest. The functional nickname for the sympathetic system, fight or flight. Anatomical nickname for parasympathetic, craniosacral. Anatomic nickname for sympathetic, thoracolumbar. So the functional nickname gives you an idea of what it does. The anatomical nickname reminds you where the cell bodies of the preganglionic fibers are located. So if you're not experiencing a threat, if you're not experiencing stress, parasympathetic dominates. Otherwise, it's sympathetic. Function of the ANS. In general, it coordinates activities of visceral organ systems, cardiovascular, respiratory, digestive, urinary, reproductive. by controlling smooth muscle, cardiac muscle, and glands. In addition, the ANS innervates intrinsic eye muscles. That's for constriction and dilation. Erector pili muscles, secretory cells in the kidney, liver, and adipose. At the liver and adipose, the autonomic nervous system is having metabolic effects. For example, during fight or flight, sympathetic nervous system tells the liver to break down glycogen and release glucose into the bloodstream. And if you always come back to exercise as your example of the stress that we're responding to, it makes perfect sense. During exercise, metabolic rate in your skeletal muscles skyrockets. They're going to need a lot more blood flow with a lot more nutrients and a lot more oxygen. Well, we're going to have to start breaking down stored nutrients in the body to supply the muscle, right, with all this extra fuel. And you store nutrients as glycogen, and you store nutrients as triglycerides. So sympathetic is going to tell adipose to break down triglycerides, releasing fatty acids into the blood, which muscle can use as an energy. We're also telling the liver to break down glycogen, release glucose into the blood, which muscle can also use as an energy source. Integration center for autonomic output is the hypothalamus. Although most autonomic output is the result of visceral reflexes. So going back to chapter 12, when we first talked about the hypothalamus, I described it as being the boss of the autonomic nervous system. Now, again, if there's no stress, no threat, so what we're all experiencing right now, rest and digest, visceral reflexes are responsible for all the activity of the visceral organs, digestive organs, and urinary organs, cardiovascular system. When there's a threat, sympathetic takes over. Let's say you were in the middle of experiencing an increase in blood pressure. Maybe because of a change in body position. Okay. You went from standing to lying down. Okay. Now we've removed the effects of gravity. Okay. We don't need as much blood pressure to force blood to the brain. So the baroreceptor reflex kicks in and acts to bring down blood pressure. Right? And you can forget all the detail. If blood pressure is high, we got to bring it down. Right? Simplify. Well, that's what the visceral reflexes are doing, like the baroreceptor reflex, trying to keep blood pressure stable. So when it starts to go up, it brings it back down. Well, if in the middle of that, someone opened the door and was threatening us, right? Now we're in stress response mode. We've got to fight this person off, run out of here, whatever, to protect ourselves. Hypothalamus will override whatever the baroreceptor reflex was doing in that moment. Right, which I was describing as actually bringing down blood pressure that was a little too high. And we're going to elevate blood pressure. Right? We're actually going to move it higher than the set point. That's what the hypothalamus can do at any given time. It ultimately has control over the autonomic nervous system, but it doesn't usually exert control unless there's a threat, a crisis. Outside of a crisis, outside of a stress situation, it's visceral reflexes that are regulating all of the targets, all of the effectors of the autonomic nervous system. So that's what I meant by that statement. Autonomic output is controlled by the hypothalamus, but most of the time, what's going on in the visceral effectors is the result of visceral reflexes, meaning the hypothalamus isn't typically involved unless, again, there's a threat. Divisions of the ANS, SNS and PNS, and of course I mean PNS as in parasympathetic nervous system throughout this chapter. For the most part, they exert dual innervation. So you can pick any organ that's innervated by the parasympathetic nervous system, heart, lung, stomach, and you'll find that the sympathetic nervous system innervates the same targets, heart, lung, stomach. But if you go through and look carefully, you'll find that there are a few targets of the sympathetic nervous system that are not innervated by the parasympathetic. Skin, adrenal gland. Now specifically within skin, blood vessels, erector pili muscles, and sweat glands, all innervated by sympathetic fibers. No parasympathetic innervation. Now, blood vessels is not specific to the skin. Blood vessels everywhere in the body. Only innervated by sympathetic, no parasympathetic innervation. So sympathetic alone controls the diameter of our blood vessels. Adrenal medulla. The adrenal medulla is the inside of the adrenal gland. And if the inside is the medulla, what do you suppose the outside is? Cortex. So we secrete a bunch of steroid hormones from the adrenal cortex, like aldosterone, androgens, cortisol. But from the inside, the adrenal medulla, that's where we release catecholamines, epinephrine, and norepinephrine. Well, what is it that postganglionic sympathetic fibers are releasing at their targets? Norepinephrine. So you could think of the adrenal medulla as an extension of the sympathetic nervous system. Could you just have sympathetic signals to the eye to dilate the pupil without increasing sympathetic signals everywhere else? Is it all or none? Is it increased sympathetic output everywhere? Or can we just target certain organs? You can just target certain organs. If all you need to do is dilate the pupils, we can do that. But what's happening during a stress response? General sympathetic activation, meaning the whole system becomes more active. All sympathetic fibers start releasing more norepinephrine, affecting all the targets, all of them. And in some cases it's excitatory, in other cases it's inhibitory. For example, digestive organs are inhibited, like stomach. Urinary system, bladder. Cardiovascular, respiratory, they're stimulated. Ventilation increases, heart rate increases, blood pressure goes up. But we're seeing all of these effects, this global effect from general sympathetic activation. Well, that's when we tell the adrenal medulla to dump a bunch of epi and norepi into the bloodstream. And that way we can reach all of the targets two ways. Innervation by sympathetic fibers and neurohormones, epi and norepi as hormones from the bloodstream. The added benefit, there are some target cells in the body that have adrenergic receptors, but they are not innervated by adrenergic fibers. If you have receptors for epi, norepi, but you're not innervated by sympathetic fibers, how in the world do you stimulate those receptors? Epi and norepi from the adrenal medulla as hormones. Right? You put those chemicals into circulation, they're going to reach every cell in the body. That's the added benefit. Not only do you have dual innervation, you typically have antagonistic effects. So whatever parasympathetic is doing to the heart, to the stomach, sympathetic is doing the exact opposite. The reason we call the parasympathetic division rest and digest is because it's excitatory for digestive functions and urinary functions. Right? The stomach's going to become more active. The gut in general becomes more active. The glands start secreting more, the muscles start contracting more. So in that case, parasympathetic is excitatory. What effect does sympathetic have on the stomach, on the gut in general? Inhibitory. Inhibits secretions, inhibits motility, the contractions of the gut. Okay, so you get these antagonistic effects. And you could go through all of the targets at least the ones that are dually innervated, right? Because some of them are only innervated by sympathetic. But for all the ones that have dual innervation, almost always those two divisions are providing opposite effects. The one exception is at the bottom here, the genitalia. And we'll talk about this in 431. It's also mentioned in the study guide a little further down. But it's the one example where sympathetic and parasympathetic aren't working against each other. They're actually working together. So you take the sexual response and you break it up into the two main phases: arousal phase, orgasm phase. What starts off the entire process is erotic stimulation, erotic stimuli. First, with the arousal phase, parasympathetic dominates. Parasympathetic output is responsible for the arousal phase, which includes engorgement of the erectile tissues, clitoris, penis. Once that erotic stimulation reaches some threshold, we transition from the arousal phase to the orgasm phase. Well, parasympathetic output, I don't want to say shuts down because it's not like a light switch, but we turn down the dial on parasympathetic, turn up the dial on sympathetic. Sympathetic then takes over. It's responsible for the orgasm phase. So there's an example of one whole process carried out by both divisions working together. But outside of that, they're always opposing each other. So if one is turned up, like during fight or flight, we increase sympathetic output to the heart to increase heart rate and increase the force of contraction. What are we doing to the parasympathetic dial to the heart? When we turn up sympathetic, we're turning down parasympathetic. Wouldn't make sense for them to both become more active at the same time or less active at the same time, because they would cancel each other out. So under ANS Overview, Part C, Divisions. 1, we talked about dual innervation and how they're antagonistic. 2 and 3, we're looking at overall functions, and we'll end with this. Sympathetic nervous system responds to stress by preparing the body for physical action, promoting increased cardiovascular and respiratory activity, while decreasing digestive and urinary activity, increasing sweating, mobilization of nutrients, pupil dilation, etc. And when you use the tiger chasing you or exercise as your example of stress, all of these things make perfect sense. Especially the tiger chasing you. That's probably the best one. Right? Because while you're exercising, what's the point of increasing consciousness, being more alert, being more in tune with your perception of sight and sound and touch? There isn't. But if you're in a threatening situation and somebody's after you, right, you're paying very close attention to every little sound. You're very observant of everything in your visual field. And that's why the pupils dilate, let in more light, increasing your visual acuity. So your overall mental alertness is enhanced by the sympathetic nervous system. So that's sort of the CNS effect. And then, of course, all those peripheral effects. Heart's beating faster, stronger. Ventilatory muscles are working harder. And as far as metabolic effects, we're trying to break down stored nutrients to make sure that your skeletal muscles have what they need to get you out of this situation, right? To run from or fight off that tiger. So again, we're telling adipose to break down triglycerides, telling liver to break down glycogen. The whole reason we're ventilating more is to get more oxygen into the blood. And why do we want blood pressure to go up? Why are we moving blood through the system at a faster rate with higher pressure? Well, blood pressure is the driving force for circulation, and we want to move blood through the system faster so that we can pick up oxygen faster from the lungs and deliver it faster to the muscles and remove the waste products at the same time. So when you look at all of the effects, it makes perfect sense as far as physical action. So we'll end with that. We'll probably have like maybe 20 minutes after the lab exam to squeeze in a little bit more. And then we've got to finish all of 14 and 15 is really short, on Thursday. So we don't have a whole lot of time left.